Let's see the third and final difference between solving an equation and solving an inequality. Again, 4 is less than 5. What happens if I multiply on both sides by a negative number? We said that if we multiplied on both sides of the inequality by a positive number, we can do that and the inequality symbol will be unaffected. Well, now 4 times negative 2 is negative 8, and 5 times negative 2 is negative 10. Which one's greater? Well, if you look at a number line, there's negative 10 and there's negative 8. The greater number is the one to the right. So negative 8 is greater than negative 10, which means I have to reverse the inequality symbol to keep it a true statement. So that third difference is if I multiply or divide by a negative number, then the inequality symbol is going to reverse. Here's a summary of the 3 differences between solving an inequality and solving an equation. The first is that the order matters. So 2 is less than or equal to x is not the same as x is less than or equal to 2. It's x is greater than or equal to 2, for example. The second is that the solution set is an interval. It's not a single value, it's many values. The third is that we must reverse the inequality symbol when multiplying or dividing by a negative number. Let's look at an example where we make use of the third difference between solving an inequality and solving an equation. If we want to solve 10 minus 4x is greater than or equal to 4. Well, if we treat it just like an equation, we want to isolate this term first, so we subtract 10 from both sides. And we have negative 4x is greater than or equal to negative 6. Notice since I subtracted, the inequality symbol remained the same. Here's where the difference comes in. I still want to get x by itself, so I'm still going to divide by a negative 4 just like I would if it were an equation. However, when I do that, I'll get x on the left and a positive 1.5 on the right, but the inequality symbol is going to reverse because I'm dividing now by a negative number. So it's going to change from greater than or equal to into less than or equal to. To represent this in the 3 notations, here we have set builder notation, the set of all x values such that x is less than or equal to 1.5. In interval notation, we have 1.5 is our endpoint. We want everything less than or equal to that. So 1.5 is going to be our greater endpoint. Our lesser endpoint, well, again, there's not going to be one. It's going to continue forever, so we write negative infinity to represent our lesser endpoint. Again, separate them by a comma. As always, an infinity gets a parenthesis. And now the 1.5 is included in the solution set because its x is less than or equal to 1.5. To show that, we use a bracket instead of a parenthesis. Finally, graphically, 0 as a reference point. There's 1. There's 1.5, our endpoint. We're going to mark that with a bracket, just like interval notation. And we want everything less than that, which means everything to the left on the number line. So we're going to shade everything to the left. This shows that every single point here where this shading is a solution. For example, I could pick 0. If I put 0 in here to check it, 10 minus 4 times 0 is just 10, and that indeed is greater than or equal to 4. showing that 0 is a solution. And I could pick any other number anywhere in this shaded area, and it would also make that a true statement, which means it's a solution. One more side note. In the alternate notation for graphical, sometimes you'll see a closed circle here, a circle that's filled in, shaded. We're not going to use that notation. We're going to use the bracket again to match up with interval notation. Here's an application involving inequalities. Ameripropane charges $2.97 per gallon plus a $5 fee per fill. Conch oil charges $2.89 per gallon plus a $20 fee per fill. How many whole gallons are required for conch to be the better deal? Well, first of all, when we say the better deal, what we mean is we want conch to be, the cost of conch to be less than the cost of Ameripropane. So this is where our inequality comes in. Now, we just have to come up with algebraic expressions for each of these two costs. Well, we want to know how many gallons are required for this to happen. Okay, so we're going to let our variable be the number of gallons. That's our unknown quantity. Conch's price is $2.89 per gallon, so $2.89 times the number of gallons, plus they have their $20 flat fee. Ameripropane, similar story, but it's $2.97 per gallon, so 297x, plus the $5 fee. So there is our inequality, and we want to solve that. Okay, so now we apply the rules of algebra we've been discussing. I want to get my x terms together and my constant terms together. One thing I could do is I could subtract 289x from both sides. Inequality symbol will remain the same because I'm only subtracting. I have 20 is less than 0.08x plus 5. Move this over, so subtract 5 from both sides. I have 15 is less than 0.08x. Finally, I'm going to isolate my x by dividing by that coefficient, 0.08. Again, I have to do that on both sides. And so I end up with 187.5 is less than x. Still less than because I divided by a positive number. Okay? Now what does that tell us? Well, sometimes it's a little confusing to have it written this way. A lot of times it's easier to understand if we reverse everything so that our variable is on the left. Now this says x is greater than 187.5. So that means the smallest whole number of gallons required for conch to be the better deal would be 188 gallons. X would have to be at least 188 gallons. It could be 189, 190, or any other higher number. This is the minimum. Okay. In words, we would say at least. So at least 188 gallons. Alternatively, instead of getting our x's on the right and our constants on the left, we could have gotten our x's on the left and our constants on the right. So I could have started out by subtracting 297x from each side, in which case I get negative 0.08x plus 20 is less than 5. Now I got to move the 20 over, so I would get negative 0.08x is less than negative 15. And when I divide by my coefficient negative 0.08, then what happens is I'll have x, because the coefficients cancel, is no longer less than, but greater than, because I'm dividing by a negative number. And this works out to a positive 187.5. Notice that we got the same answer as before, even though we did it differently. And that's okay.